Mark Ladner here again, and we're doing another video today. And what we're going to do is an industrial joint repair. And on this repair, I like to see our dealers in this environment because it gives you a chance to be in these environments where you make a lot more money, turn around these jobs a lot quicker, and there's a great area out there, or a great field out there for people that need this work done. We're going to try to put together some flyers and all for you, some literature, so that you can send these people out to target this market. We've got a lot of problems in industrial sectors where these forklifts are always jumping around these joints because the joints are exploded, they're laminated, or they're really not prepared properly in the field, even in new concrete. So we're going to go over all these systems today and try to get this joint repaired. And it's a quick turnaround. Usually I can get this done in once the material is placed and after our demolition and our tear out has been done, usually about 2-hour turnaround, depending on what we're using in caulking, because I like to caulk these joints. We're going to show you how to caulk these joints as well in these industrial environments. I want to show you the joint first and explain to you what's going on with this joint and what the problem with it is, and why these joints have exploded the way they are and why they're having problems with them. Now I want you to understand, we're in an industrial factory here where they produce a lot of products here. They've got forklift traffic all day. A lot of times it's hard to shut these places down. So we coordinated with the factory here and said, hey, we need a certain area for at least 4 or 5 hours today. If they can shut it off for the entire day to let everything cure overnight, that's even better. But today we got forklift traffic running around and it's kind of a mess. Sometimes there's a couple ways I can do these joints. If I don't want to generate a lot of dust, we'll put water down just to keep the dust down. Today we're going to try to do it without water so we get this thing done a lot quicker. We've got to do some saw cutting and some cleaning out, so we will generate X amount of dust. You have to tell this to the people here at the manufacturing facility and let them decide what they want you to do to generate, if you can generate dust or not, all right? It's a typical joint and manufacturing facility that over the years, just through the forklift traffic and the amount of weight and the force hitting these joints, have delaminated these edges. The real reason for the delamination, if you look in the joint here, all this joint here is filled with some type of latent material. Sometimes I have spillage in here, and the joints get filled up with debris. Now at this point, when that joint's filled up, and these forces hit these joints, there's no room for these joints to expand or contract, either under load, or under thermal change, which is temperature change. So they have no choice but to come out and explode and break apart like you're doing here. Now the first thing that we're going to do is we're going to come in here, we're going to cut this joint and clean the joint out with the saw. To get that joint clean, so at least I know that this joint is movable at this point and workable. The second thing we're going to do is we're coming in here, we're going to put our tape around the edges. We're going to go to the perimeters where the delamination has taken place. So we're going to go out to this point right in here and out to this point out here. And we're going to cut this particular area out. And once we get our perimeter cut, then we'll come in here and chip this joint out. And then we're going to use a specific repair material that we have to repair this joint, turned around about 2 hours of cure time on this material. And then we'll come back and recut this joint again and fill it in with what's called a semi-rigid joint filler. And the reason for the semi-rigid joint filler is once we cut our joints, we want to leave that joint edge at a 90-degree edge or a square edge because of the strength. And this semi-rigid joint filler allows this edge to be stable and not chip off. Yeah, that's fine. Sometimes get over there in the warehouse, I'll take those samples. There's a box. I think on one of those pallets right around where we're working with the same All right, we're about ready to cut this joint now. Just want to clean the joint out so I'll be sure I have a good working pliable joint there, nice and cleaned out. I'm going to try to cut it deep. In these situations, you'll usually run into steel, usually about 2 inches down. So that's about all we can cut in depth on these factory floors, because they're usually reinforced with steel number 5 bars or so. So try to stay off the steel. When I see it start to spark, I'll back off on it. Always wear your respirators when you do this stuff. You've got dust flying everywhere. You don't want to breathe this stuff in. right, first thing I want to do is now we got that joint cleaned out somewhat. The majority in here, just cutting this, that wasn't concrete dust, that was some materials, that either some resins or some old polymers that were spilled into this joint and hardened up over the years and not allowed that joint to move. So it really wasn't concrete or anything else that was in there. We're going to measure out and try to get to the farthest point out of where our delaminations are. So in this area, we're going to come out about 4 3/4 inches on this side. If you notice, the delamination it's cracked right here. So we're going to start right out at this point, right out of here. And that's going to be about, this side's going to be about 4 inches. So you don't have to have the same size repair on each side of the joint. I like to keep them somewhat close. I don't like to have a 1 inch over here and a 4 inch over here. I usually at least go half of, if this is a 4 inch here, then I'll have a 2 inch here. Just to give that more strength in that joint. So we got 4, let me just be sure what we have, 4 3/4 on this side, and we've got 4 inches on this side. So we're going to put our pattern tape down on the outside of these marks. We'll measure down on each end and cut this out with our saw, usually about 1/2 inch deep, and then we'll chip it out. Rub that real good. I want you to walk it down, Doug, and then rub it real good. Let it stick a lot harder with the whole way. Let it stay down. Now I'm going to cut this about a 1/2 inch deep. On the inside of the tape, tape's just a guide that we use. And I squared off my edges here, usually about 1 inch from the outside of that delaminated or cracked area. In other words, I want to be sure that I get all the loose areas in my cuts or in my repair. All right, this is one step that I really want everybody to understand. It's real important. A lot of the dealers don't do it, whether they don't know how to do it or just forget about it. I want to show you to point it out. I'll take my small handheld grinder with a 4-inch dry diamond blade on it. And when I want to finish up my cuts, you don't want to overcut your edges. In other words, run your saw blade outside the tape. So I'm going to finish these up with the smaller blade where I can get in here. Plus, I like to put an angle cut in here because it helps you, when you chip this out with the chipping hammer, it helps it break it off a lot more evenly. It fractures really nice when you cut at an angle on these corners here.
Memorial line 2, Peon line 2.
All right, the next thing we're doing, now we got our edges cut. I like to leave the tape down in a lot of cases. It helps reduce chipping on that edge. Kind of like when you cut for mic or something, they put down tape so it reduces chipping. Same effect here. But we're going to chip this out, and what I have here is a great little model. It's about 11-pound chipping hammer by Hitachi. I have a 12-inch, half-inch chisel bit that we're going to put on here. Great little tool for not over-tearing or overpowering the concrete. We're just going to chip out 3/8 to a half an inch of this concrete on here. At least get to the bottom of where our repair area is, or where the delamination is. So great little hammer for that, lightweight. You'll see how it really tears it up. If you notice, I'm starting on the inside and going to my cut. If I start over here, we'll have a chance of chipping that edge that we don't want to do. But see how nice that came out of that corner by diagonally cutting the corners? It makes a real big difference when you tear it out of there. point out one thing that you always have to look for. If we look at this crack, this joint, you notice we've got some more fractured area here. So what we're going to do is we're going to go ahead and cut back a little bit farther, probably back in this area here, to try to get this fractured out. That's one thing you got to look for is when you end your patch to see if there's any more fractured areas in the area, because that will pop up if we don't get that out of there. And a lot of times you'll have some chip outs outside your edge where the hammer came, or there was a loose edge in that area, a spalled edge. All I want to do is I want to take a cold chisel and I want to square this out to get some depth to it and give it some square edges. Now this way, when we go to screed our material in, we'll tape around this and let our material screed into this void so that all the patches are unified. All right, what we're going to do next is now that we have it all blown out and brushed out, if you notice I brushed it out real good to get all that fine dust off the sidewalls and off the bottom, we're going to use our Superbond 220 grout pack. And what this is, it's a very, very high bond strength polymer that we use. This is going to be a industrial gray, like a kind of a dark medium gray color. It kind of blends in with the floors. They come in about 4 or 5 different colors. We have a natural, which is sand. I believe a red, a light gray. I believe we even have yellow or green. I'm not really sure on the colors yet. We've got quite a bit of colors that we're going to have for you. A lot of times the grays are used because they come close to the colors of these concretes in these facilities. Sometimes I've used just natural because I didn't know what color they had in there. Sometimes they have a coating on the floor, they want to match it. This particular product has a special gradation of sand. This particular sand is only found one place in the world, and that's what I use it for, is because the gradations compact very densely. In other words, they make this repair very hard, very quick. Usually in a 2-hour time frame, this stuff is already set up enough to where we can go ahead and put our joint in this concrete by cutting with the concrete saw, and we're ready to go. Quick turnaround. You have to use a different type of drill to mix with this stuff. I've got this is considered a 3/4 inch drill, very low RPM, high torque. In other words, it'll turn very slowly, but it will not break down or try to bind up with this grout. This grout's very thick when we mix it, and what we're going to do is we're going to dump it in and screed it out with a screed board just to get it even. There's really 2 different ways to do these repairs. We're going to do it this way by putting the patch in and unifying it to get to all the height at the same level over that joint, because it's real important to get that joint even across the top. Sometimes I'll come in and I'll put cardboard or wax paper on it and do one side or the other. But in this case, let's do the whole joint. It'll set up quick enough to where we can come back and put our joint in there and then put our joint filler back into that joint. Now watch how I mix this up. We're going to put our polymer in a separate bucket first, and then we're going to, after we mix that up for a few minutes, we're going to add the sand slowly to it. So watch how we do this. All the A and B materials come in the bucket with the sand. We'll just scrape off the sand off of these things. We'll set that down there. So that's why we call them grout packs, because all the grout's already in the pack. This material is very, very high in set time, very quick. You have enough time to work with it, usually about 40 minutes to get it applied. After that, might as well throw it away. You should be ready to do this. Have everything prepared. Go ahead and set that in. Yeah. This does have a little bit of solvent in it, very, very low solvents. I try to keep as much out of it as I can because in some of these facilities, you won't be allowed to put any solvents down. It just doesn't have enough to really flash on you. All right. Now what I use is a real big half-inch Jiffy mixer. I have these in a little bit longer, a little bit higher poles on them or rods on them. But I want to mix this up for a few minutes. The reason why I have these big Jiffy mixers is this one right here mixes it very, very evenly and very quickly. Come dump this grout in for me, the sand. Now we're going to add the sand to it real slow. Set that on the side over there. Hold a second, bro. Let me get what I got in there mixed up. If this was a Hitachi grill, I wouldn't even touch it. It wouldn't slow it down like this. Is it? Is it? It's smoking? Yeah, let me have this. I'll push it around first.
Rest this out?
No, not yet. Not yet. I'll leave it, I like to leave it a little bit high. Leave that material just a little bit high so we can screed it in screen it in tight. Go ahead and open that other one, Doug. Yeah. Hey, thanks, Sean. Steve. For the rest of it.
What?
Yeah. That would be just the same. Shit. I shipped 2 of them to Arkansas and I shouldn't have. Oh well. The good thing about this product is once we get it set in place, and after cure, 2 hours we'll get to where it's hard enough to where we can go ahead and put a saw cut in it and actually have traffic on it. Let's say after a full day 24-hour cure, we get up to about 15,000 PSI, which is very, very durable repair in a lot of environments where tow motors go across it. We've got a lot of heavy forklift traffic. So very good stable product that will carry a lot of load in these short spans. And that's why we use it so much in these factory floors. With this product, we're going to show you in advanced schools how I'll take this product and use it to resurface like a freezer floor. It's resistant to thermal change of thermal cycles once it's placed down. Very good for going in and fixing bad delaminated, spalted holes in factory floors, or just to recap the whole floor in any different color that you want. Once this is down, this is really the finished product. Sometimes a lot of people will opt just to paint this either with one of our chemical resistant urethanes, which is the 200 pigmented, or just leave it the way it is. It really is up to the environment which they want. A lot of people like to keep their factories real clean and re-detailed. So you can leave it the way it is or cap it with any color that you want with any type of urethane, any pigmented urethane that we carry. Very compatible. But the main thing I want to emphasize is really the approach on what we're doing, why we're doing it, with this joint in mind, and be sure that this joint stays stable and works the way we want it to. All right, sometimes I'll after it sets up, it's been exactly 2 hours, by the way, I'll come in here and knock these edges down. You can use a small handheld grinder with a carburetor disc on it or a sanding disc. But I just like to knock the edges down when they transfer the load over it. But it's nice and smooth. You don't get many bumps. Do that with a rubbing brick. A lot of times I use a sanding disc. It really works good. We'll just knock it down and get that threaded out. It's right at 2 hours now. Now we've got our joint cut where we want the joint placed. In fact, I cut it full depth with the saw, 4 inches. We cleaned it out, broomed it out, blew it out real good because I want the side walls of that joint nice and clear so that our joint filler will adhere to the sides. Now we're going to put our backing rod in. We've got 1/4 inch backing rod because we've got about a 1/4 inch cut. And I've got this backing rod installer tool. This center wheel is the one that's going to push the backing rod down. And I have measured from this wheel, the side wheel, to the top of this wheel. And the rule of thumb when I put in a semi-rigid joint filler, which is what we're going to put in, is it's twice the width indicates or dictates the total depth. So the total width of this is 1/4 inch, so the total depth is going to be twice that. It's going to be a 1/2 inch deep. So this gauge is at a 1/2 inch, so we'll push this backing rod down exactly a 1/2 inch. So I'm going to start up here and watch how I do it. This gauge is great because it sets the depth of my backing rod at a predetermined depth. And I can't go any deeper with it. It's fitting in fairly snug, which is good, so that I know the backing rod will hold in place when my resin goes in. So on a semi-rigid filler, remember the reason for this filler is to keep this sharp 90-degree edge from chipping off. It's rigid enough to hold that joint in place, keep it from chipping. At the same time, it allows it to be flexible enough to allow this thing to expand and contract or move under vibration. All right, whenever I mix any type of 2-component self-leveling joint fillers, which is what this is a 2-component material. This is the panel mixer I use. It's really designed to get on those bottom edges and on the sides real good. Use just a cordless drill to mix it with. So I'm going to mix it up real good, and then we're going to pour it in a separate container and then pour it out by hand. The reason why I tape it is because a lot of people make the mistake of trying to do this without taping it, and they'll pour the material over or too much into the joint, it runs out on the slab, so it really makes a mess. If you always take the time to tape them out nice, if you do get a little bit high material in there, you can wipe it off and then pull your tape and everything looks neat and clean. So don't try to do this without taping the joints out, especially when you use a self-leveling card. I have a couple different versions of this. The one that I'm going to use the most that I'll show in the advanced schools are going to be the self-leveling joint sealer in the tubes. I've got a specially designed gun to put it out, which is a full thrust or a good solid thrust gun to put these caulks down with, or these joint fillers with. So this particular material is going to be available to everybody, but really on a limited basis. I really have the stuff in the caulking guns that work real well. This particular type of material is semi-rigid. I really prefer it in industrial areas where you have a lot of tow motor or forklift traffic involved. So you have to determine which one you're going to need the most, or which one's going to dictate what, or which job is going to dictate which type of caulk you're going to have to use, or joint filler you're going to have to use. Again, I always keep a couple gallons of lacquer thinner around to clean these tools off with. This stuff usually sets up within an hour. It's fairly quick, but you have to mix it really well when you do it. These cordless drills are great for this. It really doesn't give you too high RPM or too low RPM. It's just about right to mix this stuff properly. I don't like to whip a lot of air into it. I always keep my bit down in the material so it doesn't get a lot of air and it has to vent that air out.
Center was all beaten out.
Right.
Thanks, George.
Right.
We can see every material, but it's the work.
Right. I'm against the planner. Right.
Not a paint it all in one color.
Yeah, I think I did.
But
There it is, folks.